Okay, so in the last video we left off with the electron cloud model that was proposed by Schrödinger in 1926, and it kind of gives like a mathematical calculation of where the electrons would most likely be found at any given moment. And some people thought that the electrons orbited around the nucleus like the Earth orbits around the sun. And that's not quite true. So I want to talk about orbitals. So it's a region of space around the nucleus where electrons are most likely to be found. Now here's the part that gets a little bit tricky because they don't always go around the nucleus so nicely in a sphere like this. So the first orbital, the S1 orbital, it is a sphere. So they do go they don't go in this like circular oval motion necessarily, but they're found in that sphere around the nucleus for that first energy level. And then when you go up another energy level, so you had the Bohr model showing the different energy levels. So this one's full because each orbital can only hold 2 electrons. So it's going to go to the next orbital. Now this next orbital isn't just like this spherical shape. So the next orbital would hold 2 more electrons. So what it actually looks like is kind of like this. So this is a sphere and they're occupying this space somewhere in the sphere. Okay, so then the next orbital is actually another sphere, the S2 orbital, and it is also conveniently in this sphere shape. But then once you get to the p orbitals, the orbitals look kind of different. So they're kind of like this dumbbell shape. And then for the next orbital is another shape like that. Okay, so remember 2 electrons per orbital, and then one more p orbital would go, so that one's on the y-axis, x-axis, and then the z-axis. There's the z-axis. And then after that, the next orbitals get even weirder shaped, kind of like if you were to make an animal out of balloons. That's just the space that they occupy, so they don't necessarily follow this line of this shape here. And this isn't even in your book, I don't think, but it's just kind of interesting to know. And so this would be, let's see, 1, 2, 3, 4, 5 orbitals. So you could put 10 electrons in this, which would fill up this one here. So you could have 1, 2, and then there's 8 electrons out here. Okay, so then this one is full because it can hold 8 electrons, and then this energy level here can hold 2 electrons, and so this is completely full. It's got a total of 10 electrons, and so if it has 10 electrons, it's going to have 10 protons, and if it has 10 protons, then this is called neon, and neon is one of the noble gases is stable. It doesn't really react with anything because this energy level is full, this energy level is full, so they don't really want to lose any electrons, and they don't really want to, it doesn't want to gain any electrons, so it's just happy not reacting. Okay, let me just talk about the ground state. So remember, this is just a model. The electrons aren't perfectly in this circle, but so let's do, there's 2 protons, so 2 electrons, which would make it helium. And then let's say some energy excited one of these electrons and it gets bumped out to an outer energy level. Okay, this is an excited atom and it doesn't like to be like that. It always wants to go back to its ground state and have all of its electrons in the lowest energy level. And so this one will want to go back here. And the cool thing about that is that it's going to release light or energy when it goes back to its ground state. Okay, hopefully you can see this. Sorry for all the reflections. It's nighttime, everyone in my house is sleeping, so it's a good time for me to do this. So when we go to do our experiment 3.1, I want you to know how to build your isotopes. So let's build this nitrogen molecule, atom right now. and if I can get it to focus, we're going to find nitrogen on the table of elements. So it's got, what does it say? An atomic number of 7. Okay, so you go to your periodic table of elements, and right in between carbon and oxygen, you have nitrogen. So if it has an atomic number of 7, how many protons does it have? It's going to have 7 protons. So then how many electrons is it going to have? It's going to have 7 electrons. So let's put that up here. Okay, so I have 7 protons. And now I have 7 neutrons. And so this doesn't confuse you. So nitrogen has an atomic number of 7, but that 14 is the atomic mass number, so you're actually adding the protons and the neutrons together to get that 14. So we're going to do 7 electrons. The first energy level can only hold 2 electrons because it's only got 1 orbital. Okay, the next energy level, it actually has 4 orbitals. So remember, it's got the S2, which is a sphere, and then it's got those balloon-shaped p orbitals. Okay, so let's plug in 1, 2, 3, and they want to be farther away. 4, 5, 6, 7. They want to be far away from each other because they're all the same negative charges. Okay, so that is your nitrogen 14. Now we're going to change it to be nitrogen 15, which is an isotope of the nitrogen 14. So if we have added a number to our atomic mass, what have we done to our atom's nucleus? So we can't change the protons, because if we change the protons, that will change the atom, the element, into a whole different element. And so to get that 15, you're actually adding a neutron. And it doesn't change the charge at all. You still have the same number of protons, and these guys are negative, same number of electrons. Okay, so when you build your models, that's what you're going to do. Thanks for learning with me.